Hello, today we're going to be discussing section 3.4, which is on using similar triangles. Here, underneath our key idea, we see that when two angles in one triangle are congruent to two angles in another, then the third angles are also congruent. As we've seen in previous sections, if all three angles in a triangle are congruent, this makes the triangles similar to one another. So in this first triangle, triangle ABC, if I only knew these two angles, 65 degrees and 20 degrees, but I didn't know this third angle, and I know that in the second triangle I have two angle measures of 65 and 20, but I don't know the third angle, that would be enough information for me to say all three angles in the triangle are the same and the two triangles are similar. And here's why. If I took the first triangle, ABC, I could solve for that missing angle because I know that all three angles have to add up to 180 degrees. So for triangle ABC, if that's the one that we're focusing on first, go ahead and write that up here. I have that 65 degrees plus my second angle of 20 degrees plus that third angle, I'll call it X, has to equal 180. Now, for my second triangle, I'll call that one triangle DEF. I can do the same thing. The first angle is 65 degrees plus the second angle of 20 plus some other value for that third angle is going to equal 180 degrees. Now, if you look at these two equations, you can see that the only difference I have is what I called that third angle. In the first triangle, ABC, I called it X. The second triangle, ABC, I called it Y. But everything else about these two is the same. If we went through and solved, we would find that X and Y are exactly the same thing, and what they both are 95 degrees. Because of that, we can say that if I know that two angles are the same, that's enough to say that the entire triangle is similar to the other. In example 1, we're going to first look for two angles in the triangle and see whether or not they are the same. If we don't have two angles that are the same, we can go find the third one and see if maybe then we have two angles that are the same. But in example A, I see 75 degrees and 75 degrees. I also see 50 degrees and 50 degrees. So I really don't care what X and Y are. As long as they have two angles that are the same, we have enough information. So this one, yes, the triangles are similar. And we can say, because they have two, and I'll use my symbol for congruent, angles. In example B, I have a 63 and a 63, but these other two angles here don't quite match. But that doesn't mean the third angle that we don't know won't match. So what I'm going to do is go ahead and find that third angle in one of the triangles, and if it is what we want, then we have enough information. So I'm going to go ahead and in the first triangle, the larger triangle, in example B, I'm going to solve for X. So I know that X plus 54 plus 63 has to equal 180 degrees. X plus 117 has to equal 180 degrees. Subtracting that 117, I end up with X equaling 63. So that means this third angle here is 63 degrees. Now that's enough information for me to conclude that two angles do in fact match. So in example B, our two triangles are similar because they have two congruent angles. In example C, we'll go ahead and repeat this process. I see only the right angle that is congruent in both triangles, but the 42 doesn't match the 38, so I need to do a little bit of work to go ahead and find that third angle and see if it matches. So in the first triangle, in example C, I'll start with X, I'll add 42, and then I'll add 90, and I know that has to equal 180 degrees. So x plus 132 equals 180. And subtracting 132 from both sides, I find out that x has to equal 48. So this third angle has to equal 48 degrees. Now that 48 does not match the 38. The 42 does not match the 38. So this means that the two triangles cannot be similar. Their angles will not be the same. So our conclusion in C is no, only one congruent angle. Go ahead to take a moment and pause the video and try examples 1 and 2 on your own. In example 1, you should have a no. These are not similar. They only have one congruent angle. That congruent angle is this 28 degrees. If you proceed to solve for that missing angle, you will find that it is not going to match the angle in the other triangle. In on your own number 2, I see a matching 90 degrees, but I'm missing that third angle. Since the 24 doesn't match the 66, I do need to find it. In the first triangle, if I were to solve for this x, I would find that this is a 24-degree angle, which does in fact match a second angle in my other triangle. So this one is yes. They are similar because they have two congruent angles. In example 2, you plan to cross a river and want to know how far it is to the other side. You take a measurement on your side of the river and make the drawing shown. First, we're going to explain why triangle AB and C and triangle DEC are similar. And then we're going to go ahead and find the distance x across the river. So looking at these two triangles, first off, I see that they're both right angles. They don't give us values, however, for any of the other angles, so it might be tempting to say at first that we don't have enough information to answer this question. However, we can use what we know about angle relationships to find the information that we need. Looking at this x right here, we can see a relationship of vertical angles between two of the angles. That tells me that the top angle in triangle ABC is similar to that other angle in triangle DEC. Because of this, we do in fact have similar triangles. So A, they are similar because angle B is congruent to angle E. They're 90-degree angles, or they're both right angles. Also, we know that angle ACB in the first triangle is congruent to angle DCE in that second triangle by vertical angles. Part B, we're going to find the distance across the river. Since these are similar triangles, all we need to do is find our scale factor, and then multiply to find that distance across the river. We have enough information to find the scale factor if we look at our corresponding parts. This part of my triangle, side BC, will correspond to side CE in my other triangle. That means the relationship between the two triangles has a ratio of 50 over 40. Now, if I'm trying to find the distance across the river, which is this side x, I need to compare that with the 60 feet, or side AB of the other triangle. Since the 60 feet comes from the side of the triangle that has the 50 feet, that will be in my numerator. So I'm going to let this equal 60 feet over the side that I don't know, which is x. From here, there are many methods to solve. You can cross multiply, you can reduce, you can try and make the numerators the same. Just to keep things simple, I'll go ahead and cross multiply. X times 50 is 50x, and that's going to equal 2,400. From here, I divide by 50, and x is going to equal 48 feet. So the distance across the river is 48 feet. Go ahead and take the moment to pause the video and try on your own number 3. When you're ready, go ahead and play the video to check your answers. Now they're asking us, what if the distance from A to B is not in fact 60, maybe it is 55 instead? We want to know the distance across the river, so we set this up almost exactly the same, except instead of 60, we will have a distance of 55 over x. From here, I'll solve by making the numerators the same. So first, I'll go ahead and reduce. I get 5 over 4 is equal to 55 over x. To make the numerators the same, I'll just multiply by 11. I get 55 over 44 is equal to 55 over x, which tells me since the numerators are the same, the denominators must also be the same. Therefore, x must equal 44, and the distance across the river is 44 feet. Thank you so much for watching. I hope you enjoy the rest of your day.